Hello, for this problem we have a force vector given in the x, y, and z directions. So we know the overall magnitude is 45 degrees, and we've got two angles to determine the direction. And so what this is in 3D space, we've got the xz plane, which is kind of lying flat, and then y direction is going up. And so I swing out 20 degrees in the xz plane for that first triangle, and then from that point in the xz plane I'm going to go down 30 degrees from that. And so I've got these two angles here, and I've got two triangles really. These are two right triangles right here. And so I'm going to say triangle 1 and triangle 2, and those two right triangles are going to help me find the x, y, and z components of the force vector. So starting with triangle 1, this is a right triangle. And that is my right angle right there. And so I know that this is kind of, this top leg is this piece right here. This vertical leg here is that piece right here. And the hypotenuse is the actual force vector. So I know that the hypotenuse is going to be 45 newtons. And then my vertical leg here, this is actually my y component because it's going in the y direction. So this part right here is Fy. And then this leg on the top here is this piece right here. So it is not the x component or the z component, but it is in the xz plane. So I'm going to call this one Fxz, and I'll use that later. So now I have, and I also know this angle of 30 degrees here. And so I go, from the xz plane, I go down 30 degrees from there. Alright, so I've got two components. I've got Fxz and Fy. And so the Fxz piece of this is the adjacent side to my angle. And so this is simply going to be 45 times the cosine of 30, and that is 38.97 newtons. And the Fy component over here is the opposite side, so that is 45 times the sine of 30. And this is also, I can kind of see that this is going down, whereas the y direction is going up, so this is actually going to be a negative number. And so this is negative 22.5 newtons. Alright, so I've got one of the three components here, and then this xz is going to help me figure out the x and the z components. So I need to break this down into those two parts. And to do that, I'm going to use my second triangle. And so my second triangle is here, outlined, and if I draw this right here, this is lying flat, and this actually is my right angle right here. Looking at it in 3D, it doesn't look like a right angle, but if I imagine looking down at it from the y direction, that would be a right triangle. And this angle over here is 20 degrees. Alright, so this part over here is in the z direction, that's going to be Fz, and this part right here is in the x direction, so this is Fx. And the hypotenuse of this triangle right here is the leg up here, and so Fxz is my hypotenuse. And that is 38.97 newtons. And so Fx, my x component is simply going to be the hypotenuse, Fxc, times the cosine of 20, since it's the adjacent side of my right triangle. And that is going to be 36.62 newtons, because I take this number, I add the cosine 20, and simply solve it out. Alright, so for FZ, it's going to be the hypotenuse, FXZ, which I have up here, times the sine of 20, since it's the opposite side of my right triangle. So FXZ times the sine of 20 degrees. Alright, so now I have my X, my Y, and my Z components of this vector. I just want to double check the signs are right, and so Fx, I should be going in the positive X direction, that's right. I'm going in the positive Z direction, that's right. And I'm going negative Y direction, so that's right as well. Alright, so I rewrite this in vector form. So I use my square brackets. X component is 36.62. Y component is negative 22.5. And Z component is 13.33. And the units of this vector, these are all in newtons. So with that, that's the end of our video. Thank you for watching, and I hope to see you again.